Hi everyone, in this video we are going to discuss about the standard normal table and how to find the Z alpha from the standard normal table and use this standard normal table in solving the problems related to normal distribution. So here I have shown a standard normal curve or a normal curve which is a bell-shaped curve. So we have already discussed the properties of the standard normal distribution in a previous videos where we have told that this is a bell-shaped curve and it is symmetric about the mean mu. So if x follows normal with mean mu and variance sigma square, this curve is symmetric about mean x is equal to mu where mu is the mean. And Z is a standardized random variable where Z is equal to x minus mu by sigma, and since Z is equal to x minus mu by sigma, the expectation of Z is equal to 0. So since the expectation of Z is equal to 0, this standard normal curve is also symmetric about 0. So we are going to consider the standard normal curve. The Z is equal to 0 here, and since this is symmetric, for probability of Z greater than 0 is equal to probability of Z less than 0 is equal to 1 by 2. And what is our area of interest is we need to find this Z alpha such that this area is alpha. This shaded area is alpha. So that is the way how we are going to use this table in order to find the probabilities or these Z values. So this table, this statistical table is a tail probability under the standard normal distribution is as follows, where probability of Z greater than Z alpha is equal to alpha. These alpha values are given in the margin where Z is from, on the column, first column we can see that it is 0.0 to 3.0. So we have almost 30 entries here. Similarly, as in this row, in the first row, in the margin, we have 0.00, 0.01 up to 0.09. So this is how the margin is, and these are the Z values. And what is inside this table? What is inside this table is it has 4 digits after the decimal. So those are the probabilities. So if I am to find a probability where probability of Z greater than, suppose 0.05, what I have to do is I have to go to this, and I know 0.0 is the first line. So what I'm going to do is, I hope it is clear, yes. What I'm going to do is I'm going to select that line 0.0 and corresponding to which I can see a 0.05 here. So I am going to select this column. So the cross section of this row and this column will give me 0.4801. So the probability of Z greater than 0.05 is 0.4801. So this is that probability value. Similarly, if I am to find any other value, for example, probability of Z greater than 1.87. Suppose it is Z greater than 1.87. So if I am to find 1.87, for the first points, I'll have to go through the first column. So going through the first column, I can see a 1.8 here. A 1.8. So since I can see this 1.8, what I want is the second digit after the decimal point. So to know about the second digit after the decimal point, what we are going to do is we are going to the first row and we are going to find the 0.07 here. So to find the cross section of these both, we will get it as 0.0307. So this is the value I have got as a probability, where probability of Z greater than 1.87. So if I draw a graph corresponding to this, if I draw the normal curve, so Z greater than, this is Z is equal to 0. So Z is greater than 0.05 is so near to this Z is equal to 0, and this is the corresponding area. So this is equal to 0.4801, and this point, this corresponding point is 0.05. Similarly, if I am to draw this 1.87, I can draw it to this end where it is 1.87 and this value is 0.037. So this is how we can find the values, or if we know the Z alpha values, we can find their corresponding probability. Similarly, we can find the converse also. If we know the probability, we can find what is this Z alpha. So we shall check how can we do that. So in order to find the Z values when the probabilities are given, what we are going to do is, suppose greater than Z alpha, for alpha is our equation. So if this alpha is equal to, suppose what I am going to do is, I am going to take it as 0.21. So if this probability is 0.21, what I want is, I want to find this Z alpha. So in order to find this Z alpha, what I am going to do is, I am going to the table and going to find this 0.21 or a value near to this 0.21 from this table. So it begins from 0.5, because when Z is greater than 0, it is 0.5. So it begins from 0.5 and it ends to a value that is nearer to 0.0 or nearer to a 0, because it is 0.001. So I can search for a value 0.21 inside this table. So if I search for a value 0.21, what I can see is, if I comes to this 8th row and all, I can see a value 2.09, 0.209, 0.206, 0.2033, 0.2005, etc. So from here, a value that is much nearer to this 0.21 can be taken as 0.2090. I find this value much nearer to 0.21 on rounding. So since this value is much nearer to this, what I have got is this value. So to the left margin, what I have got is 0.8. So Z alpha is equal to 0.8 in the first digit, and in the second point after the decimal it is 1, because it corresponds to 0.01. So our Z alpha is 0.81. So if probability of Z is greater than 0.81, our value is equal to 0.21.